Hi, I'm John Paulraj. In this video, we will continue to solve question number 2 from paper 3, time zone 1, May 2025 for IB Mathematics Applications and Interpretations. Here we go. So this is where we stopped at, and we're going to continue from this part. It says, in an effort to increase the mean weight of his eggs, Farmer Giles gives the chickens a new food, chick crackle, for 1 month. Okay, he then randomly selects 10 eggs and weighs them. So he selected 10 eggs after he's given them some feed, okay, a new feed, okay. I hope I'm sharing the entire screen, all right. His results in grams are shown in the table. So this is the results for those 10 randomly chosen eggs, and that's put in the table. What's the question given? Asked. They are asking, Farmer Giles assumes the weights of all his eggs are still normally distributed. That's important, but believes the mean and the standard deviation of the weights may have changed. So basically, he's believing that the mean and the standard deviation may have changed from whatever initially it was, 52.0 and 3.7 earlier on, the normal distribution. But this is now after the feed, after he's given them that special feed, chick crackle, and then he's weighed, and he says that, you know what, the mean and the standard deviation probably have changed, okay, but it's still following a normal distribution. C, perform a suitable test at the 5% significance level to investigate whether the mean weight of his eggs has increased. Now you want to find out whether it's increased, because you know what, he was saying that maybe it has changed, but now you know there's a certain direction, one-tailed test. Now let's just first understand which test we're going to use. Okay, there are 10 eggs, not 1 egg. You're not comparing whether 1 egg in comparison with the population mean, right? 10 eggs, it's a sample. It's 1 sample of 10 eggs, okay? What else do we know? Do we know the population standard deviation or the population variance? Clearly, no, because you see, look at this. He believes that they have changed. Obviously, the mean and the standard deviation have been changed because of that that special feed, that new feed that is given. So in this case, we are going to use a one-tailed. One-tailed is because we want to know whether it's increased. Okay, this change is an increase. We are going to use a one-tailed t-test. Okay, one-tailed t-test. Why t-test? Because we are unaware of the population standard deviation. It could have been changed. It could have changed. And so in order to do this, we're going to do it on the calculator, but we need to write down the hypothesis clearly. So this is 1C, right? Let me just do that first, okay? Here we go. Not 1C, 2C. Why do I keep saying, okay, 2C. So first we will write down, let me just read again, okay, what are they asking? This is important. This is what I meant by, you know, going back and forth. Read the question again and again, so that what you write, because you know, quickly the first thing I see is that children jump to the calculator. You know, anything happens, first jump to the calculator, read the question, answer, because they're just going to, you know, mark you based on what you've written. Perform a suitable test at the 5% significance level. Okay, it's a 6-pointer, and maybe if you want, you can write down what test you're going to use. Okay, so that you know what the examiner knows what you are going to do. So you said we will perform a one-tail t-test. I don't think we need to justify this point, but as long as you're convinced why, you know, and this is where sometimes students make a mistake. They use a z-test here because, you know, yeah, earlier we did, it said a normal, and you know, anyway, so you understand why we're using the t-test, because the population standard deviation is not known for this particular sample of 10 eggs, okay? So we can then write the null hypothesis as mu is equal to 52.0, and the alternative hypothesis mu is greater than 52.0. Okay, that's clear, right? Because, you know, the original mean before the feed, the population mean was 52. Has it increased or... Yeah, that's what we want to know. Has it increased? So the data is given to us in this table. We're going to enter the data in a list, and so let's just jump to our calculator. And to do this, what we are going to do is that let's just enter a list and spreadsheet page. Okay, so I'm going to go Control Doc, enter, bring a list and spreadsheet page. I'm just going to call this list 1. List, and put an underscore. You don't want to put an underscore, don't put an underscore, okay? And I'm just putting the 54.5. Enter the values as accurately as you can. In fact, enter it as it is, okay? Not as accurately as you can. 52.4, 50.4. Be careful as you're entering. 54.3 and 54.2, 53.1. You know, one of the things I was just realizing as I'm entering these things, in the exam, you can't read it aloud now. You're in an examination hall. So, yeah, I empathize with the students. 53.5. Okay, do we got 10 entries? Yeah. Every value, please be very careful as you enter this part. You know, that is why every time when I tell the students, you know, practice as you're performing the exam, you know, take your calculator, because even punching the numbers is taking time, you know, those keys, you know, so practice as you would perform. You'll just improve your timing. Okay, maybe the first time you might be a little slow, but the second time, the more you do, you'll get better at it. So use your calculator in every practice session that you have. That's the list that we've got. Now you can come back to our calculator screen. You can perform the test here. In fact, you can even perform the test even from there. Okay, maybe the next question we'll do that way, but stat and stat test, and we said it's a t-test, one sample. So here we go. The data input method is it's coming data as opposed to stats. We have the data in that list. So you say okay, and mu naught we're going to enter it is that 52. That was the original mean. Okay, so 52.0, and list we are looking at list 1. Frequency list, don't worry about that. That's just 1. Alternative, okay, it's not, we're not saying it's not equal to, it's one-sided, and we're saying that it's increased, okay, but you don't write mu naught, okay, you write what it is, 52.0, and remember all this has to be entered, okay, to show the calculator, to show the examiner that you understood the working, or you know what you're going to do, right? So we can say using GDC, I'm just going to show this in a minute, using GDC, on the GDC, how you used is what you can write down, okay, so you can write down the GDC entries. You can say t-test, and you've got mu naught written as 52.0. You've got list, and you don't have to show them. You can just say it's a certain list called list 1, and then the frequency list, that's not important, of course, but you can still say 1, and the alternative hypothesis is selected as HA mu greater than mu naught. Okay, now in some, I think in the US they use HA instead of H1, but that's okay as long as you understand that's alternative hypothesis. All right, having said that, let's just jump back and hit enter and see what you're going to get. You're going to get the t statistic as 1.35. The p value is 0.105. Those are the things that we are interested in. Okay, the other stats, if you're doing any higher order thing, you know, degrees of freedom, x bar 52.7. Okay, that is for this set of data. Okay, and 1.55 is the unbiased estimate. That was a word that I kept, you know, unbiased estimate for the mean in the earlier video also, that phrase, unbiased estimate, okay, Sn minus 1x, okay, for the standard deviation. So anyway, we are right now interested in the t statistic, t value, and the p value in particular, okay, so you can write down both of them on your answer script. So you can say t value is 1.35 and p value is 0.105, and then you can put down your analysis. You can say since the p value 0.105 is greater than, I think we're performing 5%, yeah, so 0.05. okay, since the p value is greater than, if you write down p value greater than significance level okay, this part is important. We do not have sufficient evidence to reject the null hypothesis. The null hypothesis was that when you say null mu is equal to 52.0, that means there's no change. You know, before the feed, the population mean of each egg was 52 grams, right? And Farmer Giles in the question says that, you know, if the question said that after the feed, has it changed? Has it increased? There isn't sufficient evidence. We're not saying that it hasn't changed. It may have changed, but maybe based on the sample of these, the 10 eggs that we are looking at, based on that sample. This is just interpretation because look, your courses applications and interpretation, you should be able to interpret it even if it's not asked. So don't just treat statistics as numbers and calculator functionalities, okay, no matter how cool it is, but understand what is going, okay, understand what is going on. 52.0 was your initial or the original believed the mean of all the eggs, okay. But now because of the feed from the sample of 10 eggs that we have looked at, okay, we do not have enough evidence is what we're saying. We're not saying we're going to reject the idea. It may have changed. Who knows? Maybe in another sample it could have shown something differently. But we say that we do not have sufficient evidence. We do not have sufficient evidence. Okay, so don't say that directly that the mean remains the same, because right now we're saying that in other words to say, we don't say that we accept the null hypothesis. That's not what we're saying. It could have changed, okay, is all I'm saying. But the way to say that, okay, is we don't have sufficient evidence from our sample of 10 eggs, okay. So this sentence is good enough to say that, all right. Okay, now the next part, what is the next part? I'm just keeping an eye on the time also, okay. It says find a 99% confidence interval. 99% is what we want for the mean weight of Giles's eggs after feeding his chickens that special food, okay, chick crackle. So again, we can use a calculator to perform this for us. So, but just write down whatever we need to write down. So this is 2C. Let's go to 2D then. 2D, confidence, 99% confidence interval. And when we do that, of course, we are using x bar plus or minus that unbiased estimate. Okay, so it's basically sigma over, not sigma bar, man, sigma over square root of n. That is what we're looking for, okay, with the 99%, remember. And so we'll jump, but you're not doing the calculation. You can check that if you want to later on, but I think the calculator will do everything for us. How lucky you guys are. But if you had to, in some courses, then, you have to use a formula and you need to know when to use that unbiased estimate for that sigma, okay? So this is already calculated for us because we had entered it on our data. So we can simply go to statistics and go to confidence intervals and just say we have used a t interval, right? We have used a t interval and the input is data as before. List is coming from list one, and the confidence level, you can change that and you can write that as 0.99 because we want that. Again, as I always say, you can write down using GDC, and this is a good habit to practice. Write down your input, okay, whatever you see that. So that the examiner is clear, okay. So using GDC, what did you write? What did you use? You used the t interval, okay. And you had the list coming in from a list called list underscore one. You had the frequency list as 1, and the C level is 0.99. Just copy down exactly what you have or what you can see on the calculator, and then you can hit enter, and you can see that the lower is 51.1. The upper is 54.2, okay. So using the GDC, we've calculated the confidence of 99% confidence interval as 51.1, comma 54.2. As I said, we don't need to use a formula to calculate, but that is the formula. Oh, I'm not even sharing the screen. How embarrassing. Okay, here we go. Let me just repeat what I said, okay. 99% confidence interval, that was the formula, x bar plus or minus sigma over square root of n, and then using GDC, write down the syntax, show that you know, and not just the syntax, you're writing down what you actually entered on the calculator, and then the calculator, whatever it shows you, C lower, this is the C lower, and this is the C upper, it says, right, okay. Everything else is given there. Yeah, we've copied down this thing. Now, they have not asked us to interpret. They have not asked it to interpret, but because, as I said, because the course is talking about that, this is not the probability that your true mean, the true mean is like, what it was, 52, even though it lies here, right? 52, even though it lies here, it's not the probability. It's not like 99% probability. It actually means that, if you were to do this sampling of 10 eggs, or a large number of times, okay, then 99% of the times when you were to find, if you were to find the confidence interval, 90% of the times, every time you take that sample, the true mean will lie in that interval. Okay, or another easy way to say is that you're 99% confident. You're 99% confident that the true mean lies in that interval of values between 51.1 and 54.2. Okay, that is how to interpret this. Fine, let's do D. Now let's see what's the next part. Okay, let's see whether you can complete to E also. To analyze further, can you see the question? Okay, to analyze further the effect of chick crackle, Giles decides to choose 8 specific chickens. Now this guy is getting really scientific, man. To analyze further the effect of that special food, he decides to use 8 specific chickens. He weighs a randomly selected egg from each chicken before feeding the chick crackle. He then weighs another randomly selected egg from each chicken after feeding them that chick crackle for 1 month. For 1 month he's doing this. This guy is amazing. He's probably doing some math or something like that to determine whether the new feed has the required effect. The required effect is basically he's looking whether the mean weight has increased or not. His resultant grams are shown in this particular table, table 2. So the chickens are identified as A, B, C, D. So the chicken remains the same, all right? It remains the same before and after the feed. He's picking up 1 random egg before giving the feed and after giving the feed for almost a month. He's doing this thing, and the mean weights, okay, the mean weights before and after is recorded here. The question is in part E is that state a suitable test that Giles should use. 1 point. Okay, because you're using the same chicken, all right? You're testing the same chicken. The chickens are, before and after, you're testing before and after, right? You want that before and after weight, right? To see whether there's a change, right? They are dependent, right? It's the same chicken. It's the same chicken. Nothing about the chicken, the genes, or the weight of the chicken, the mood of the chicken. None of that has changed. So chickens are dependent. We're going to use a paired t-test. It'll be 1 sample. It'll boil down to 1 sample. Okay, it'll be 1 sample because you're looking at the difference. What we are going to end up doing is the difference. We'll have to make 1 more column and call the difference, and we're going to study the differences, whether the differences are positive. After minus before. After minus before. I hope this is clear, right? So we are going to use a t-test. Why a t-test? Because again, we don't know about the population standard deviation, right? We don't know because, as I said, it may have changed, all right? So we don't have that information. Why paired? Now this is another place people might make a mistake. Students might make a mistake. They can choose a 2 sample, all right? But keep in mind that the study is being done on the weight of the egg has that been changed for every chicken, and the chicken has not changed. There's no variation in the chicken, all right? That's the same chicken being used, and obviously, different readings, X bar, the mean weight before and the mean weight after over a period of 1 month. So be very clear that it is the same chicken, and obviously 8 different chickens. The study is being done. So what we are actually going to do is it's a paired t-test, and it'll boil down to 1 sample because we're going to do the difference after, the weight after and the weight before. Okay, so let me just see how I can write down in 1 sentence for 1 point. This is 2E, 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 and they have not given, explain the reason why. If they said then you should have said that. So we will use a 1 sample paired t-test. Okay, I've explained why t-test, because the population standard deviation is not clear. I've explained why paired. Okay, same chicken. The difference of after minus before is what we are interested in finding out. Okay, Giles should use. So maybe you should answer it as not we, Giles. 1 second. Giles should use. Let's answer it that way. Giles should always answer in the context of the question. 2E, all right. That's 2E part 1, I believe. It was part 1. State 1 assumption that Giles needs to make before carrying out the test. Well, the assumption should be that the the differences must be approximately normal. Okay, it should follow the normal distribution. That's one of the assumptions for every t-test, right? So that is the assumption to be made. So let me just write that quickly. This is E1 and 2. E1, so this is E part 1 and this is E part 2. Assumption that the differences in weights, and you can specify what you mean by that. Okay, so you can say after minus before. The differences weight of the egg, because it's one egg, right, over a month, is normally distributed. Hope this makes sense, and I think that's all the time that we have for this particular video. If you found this video useful, please make sure that you share this video with a friend, and subscribe to my channel. If you visit my channel, there are several other videos on my YouTube channel. Do check them out. And if you have any question, any topic that you'd like explained, do mention that in the comments and I will make a video for you.